Hello guys, welcome to my tutorial class, which is chemistry. So today we are doing more concept, and to be specific, under more concept we are doing what is called empirical formulas and molecular formulas. So we are doing empirical formulas and molecular formula. So this is what you're doing today, and I have observed that most of the students have difficulties on how to find what is called empirical formula and molecular formula in chemistry, and the topic, which is more concept. Guys, stay with me in this video. I am going to explain step by step what an empirical formula is, what a molecular formula is. Then later I'm also going to explain how do you answer questions that has to do with combustion analysis, where they are also going to ask about you finding the empirical formula and the molecular formula. Now, without wasting our time, let's start. What is an empirical formula? EF. So an empirical formula, it is the formula. Yeah, it's a formula as according to its name. It is the formula that shows the simplest, or in other words, the lowest, or the simplest. You can use the word lowest ratio of atoms in a molecule or in a compound. So if we say this is an empirical formula, just talking about the formula that shows the simplest ratios of atoms in a molecule. What we mean by that is, let me give an example here. This is an example. We all know how glucose is written. It's written as C6, H12, and O6. Right? So if I look at this, to me, this is the actual formula. This is the true formula of glucose. Quite good. Now, if they say empirical formula, it's a formula that shows the simplest ratios of atoms, or the lowest, right? Can we see 6 here? Can we see that? I can simplify this formula by dividing 6 throughout, and what I am going to obtain to be 6, 1, then H2 and O1. This means C, H2 and O there. So what I have obtained here is what is called an empirical formula, because it is showing me the lowest ratios of atoms in a molecule. So that is what is all about an empirical formula. Now, what matters in chemistry, or in your tests, you guys, or in your session exams, is how do you determine this formula? How can you get the empirical formula? So this is what I'm going to show you, and these questions, they come in most of the papers. I've never seen more concept questions without asking about empirical formula and molecular formula. So now, let's start. How do we determine the empirical formula? So, how to determine the empirical formula? Let's start, guys. So, how do we determine determine an empirical formula? How do we determine an empirical formula? So it's very simple work, and that you guys are going to understand this. It's very simple. All right, so let's start. How do you tell, or what are you going to be given for determining the empirical formula? Okay, so an empirical formula, this is what to be given. So if they ask about to find the empirical formula, they're going to give you either percentages, or the masses, either of these two, of the elements in the molecule. So when they're trying to ask, or when they're asking you about the empirical formula or the molecular formula, what they're going to give you are percentages or what? Or the masses. Okay? So now, how do you work out with these? It's either you'll be given the percentages or masses. When they give you percentages, it means you're doing what is called percentage composition, okay? When they give you the masses of the elements, it means that those are the masses that are contained in what? In that particular molecule. And we assume that the percentage and the mass, we are assuming that when you add all of them, they'll give you 100, either 100 grams or 100% when you're dealing with the percentages. And when you're dealing with the masses, they have to add up to 100 grams, okay? And these masses, when they give you masses, guys, remember, your masses has to be in grams. So when the masses has not been given in grams, meaning you have that duty of you converting those masses into grams, then you are good to go. Now, let's look at the examples. How do you determine the empirical formula? But before the examples, I am going to give you the general solutions, okay? So here, remember that you'll be given the percentages or what? The masses of the elements, of the individual elements in the particular compound or in the particular molecule. So what do? These are the steps you have to follow. What are the steps? So these are the steps you have to follow. Step number 1, what you do is you arrange those elements that they have given you. You arrange the elements in any order. The order doesn't matter. For example, you can say, for example, carbon here, you say hydrogen here, you say oxygen here, and other elements. That's what you do with their respective percentages or masses, okay? So either percentage here or the mass, the percentage here or the mass, the percentage here or the mass. That's the first thing that you have to do. Then your next step is you doing so once you arrange the elements like that, the second step, what you do is this. You're going to divide, all right? You're going to divide the percentages or the masses by the respective masses of elements, by the respective mass numbers, that's not mass numbers, or molar masses of the elements. For example, the way you did for carbon, that mass you divide by the molar mass of carbon, which is 12.01. If it is carbon, if it is hydrogen, maybe that percentage or that mass which you are given in the question, you divide it by its molar mass, which is 1.008. If you have oxygen, you divide that mass or percentage divide by its mass, which is 16.00. Then once you do that, you divide, right? The second step is the third step is you have to check out the smallest, or the simplest or the smallest, okay, number, and divide it through out. So from the numbers that you obtained in step 2, you have to check out which one is the smallest amongst the numbers that I have obtained. Then that one is the one that you're going to divide with everything throughout. Then the last step is, this is what matters the most. The last step, you have to make sure that when you're answering this question, you guys, your ratios must be whole numbers. The ratios must be what? Must be whole numbers, must be positive integers, must be positive, must be whole numbers. We don't need decimals when you're answering the empirical formula or the molecular formula. We need the atoms with their numbers which are positive integers or whole numbers. We don't need decimals. Now listen, how do we avoid this? In the process of you finding the empirical formula, there will be a step where you have to round your values to 1 decimal point. I'll show you in the examples. You have to round your values to 1 decimal point, right? Now, the rules are that you round off, or rather up, if that obtained 1 decimal point of your ratio is less or equal to x.2, x.2, and if the same obtained ratio, maybe other one, it is in the range of must be greater or equal to x.8. You round off or up. But when it is in between, so don't round off. Remember this. Do not round off, or rather up, if the ratio you obtained is in between x.8, x.2, x.2 and x.8. But what do you do? What do you do here? Instead, you have to find a factor, right? So instead, what do you do when you have, let's say you obtain the value which is like 2.3, all right? Maybe this is a ratio to 1 decimal point, maybe 5.6. These numbers, you can't round them off or up. Here we violate that rule to say you round off when it's above 4, you add 1. Here we violate that rule. So here you're saying you don't have to round off as long as it's in between x.2 and x.8, but you have to look at the factor whereby once you multiply with the same ratio that you obtained, it gives you a number that can be in the range that can be rounded off or up. So when it is in between, do not round off or up. Instead, find a factor. Okay? So instead, you find what? You find a factor. So find the factor. You start with a 2, lowest common factor. Start with a 2. Try 2. Let me give an example. You start with a 2. I'm not saying use a factor of 2. You start with a 2. Meaning if 2 is not working, you change a factor. Go to another factor. Let's assume that your value that you obtained was 1.3. 1.3 is in between x.2 and x.8. In this range, do not round off. X can mean any number. But what matters is what number is after the decimal point to 1 decimal place. So if it is 3, if it is between 3, it's between 2 and 8. Don't round off that number, right? But find a factor that you are going to multiply with, then so that it gives a number that can be rounded. For example, 1.5 is a ratio. You can't round off this one. Find a factor. Let's say we use a 2. If you multiply by 2, you're going to have the value which is 2.6. Now 2.6, again, it is in the range of x.2 and x.8. Again, we can't round off this number. So we can't use 2 as a factor. Instead, we are going to change a factor. Don't use that. So we're going to use a factor. Let's go to 3. We change a factor. Let's go to 3. So what are going to have? We're going to have 3.9 as a factor. All right. Now, have you seen 3.9 once you multiply? It is in the range of greater or equal to x.8. What does that mean? This means that this one can be now rounded off to what? What are you going to do? This time, you are going to have now the answer, which is a 4. That's what we do. Now, these are just general solutions that I have given and what you have to do. So now, in my next video, I am going to explain. I'm going to answer a question based on the empirical formula and see what we've looked at, how we applied them, how do we round off, how do we round them up, what do we do if it can't be, if it can't be rounded off, if it is not in that range of x.2 and x.8, what do we do? So wait for part 2 of the video and I'm going to solve the questions.